Thank you. Over the years, the United States Air Force has developed some of the most dangerous and advanced weaponry, from cutting-edge fighter jets to next-level drones and hypersonic missiles. But their latest weapon is so advanced and powerful it can destroy everything in its path. What is this weapon and how does it operate? Join us in this video as we explore why the U.S. Air Force admitted they've created something so advanced that it will destroy everything. The power of any nation is largely dependent on its military might. For a long time, the United States has held the position of world power and consistently invested time and resources into developing advanced military equipment. The U.S. Air Force has pushed the boundaries of military aviation and weaponry, setting the pace for other world powers. Some of its earliest mind-blowing inventions include the fly-by-wire F-16 in 1978 and the development of unmanned aircraft like drones. But now the U.S. military has something far more powerful than all the other innovative weaponry it has brought to warfare, something that makes even fighter jets seem like toys. This new dangerous weapon is called the Tactical Ultra-Short Pulse Laser, TUSPL. Although ultra-short pulse lasers date back to the 1970s, this is a massive upgrade from typical laser weapons. The U.S. Air Force has developed a next-generation, highly versatile system that can destroy anything in its way and be integrated into various military platforms or vehicles, usable by the Army and Navy without major modifications. Despite being in the prototype phase, the weapon has already topped the charts as one of the most impressive advances in weaponry, succeeding in all field tests and awaiting the right conditions for deployment. If war breaks out in the future, this weapon will almost certainly come into play. The Tactical Ultra-Short Pulse Laser is a dynamic system that fires an incredibly powerful beam with a peak intensity up to 1,000,000 times higher than the sun, producing an extremely hot, high-energy light capable of delivering precise, powerful strikes on targets. Its beam can cut through metal, shatter glass, and even destroy electronic systems in less than a second. Housed in a compact, portable frame that at first glance might be mistaken for a camera or a stage light, the design allows easy transport by military personnel. Despite its unassuming appearance, the device generates ultra-short, dangerously intense pulses directed at targets. And intense that they can cut through steel and similar materials in a flash. This weapon isn't just a destroyer. It can also be used for non-lethal warfare such as blinding enemy combatants or disabling electronic devices. One remarkable feature of this new U.S. Air Force laser is its speed. Pulse durations range from femtoseconds to picoseconds, meaning it can destroy a target before they even know what hit them. On average, this laser releases 1,000,000 megawatts of energy in 200 femtoseconds. 1 femtosecond is 1/400,000th of a second. Because of the ultra-fast pulse duration combined with extremely high beam intensity, it can cut welds and even melt materials while being so precise it slices without causing heat damage to surrounding areas, a rare and valuable property for military applications like target identification and instant point of kill. Unlike normal continuous beam lasers, the pulse laser uses ultra-fast light flashes to destroy matter. When fired, the energy is absorbed by the target material, causing it to flare, expand, and generate a massive shock wave and tiny surface explosions that result in a clean, precise cut. Tests so far suggest its usefulness will extend beyond the battlefield. Experts believe this technology could revolutionize many industries, from manufacturing to security, and you might someday see scaled-down versions in parking lots or integrated into home systems. The secret to its power and speed lies in the mechanics. A special amplifying material is excited by an electrical current to emit photons, which are routed through mirrors and lenses that shape and focus them into concentrated ultra-short pulses. Beyond raw power, the system offers adjustable pulse duration and energy levels, letting operators tune pulse length and beam strength, and can perform nonlinear optical processes, interacting with matter in unique ways that ordinary lasers cannot. After decades of effort, the Army appears to have realized the long-sought dream of releasing petawatt-scale energy in the blink of an eye. Plasma from solid materials, when adjusted to the right setting, the TUSPL can do far more than raw destruction. And with all these functionalities, no one yet knows how capable this tool will become as it receives further upgrades in the coming years. Experts already predict that the possibilities with this innovation could far exceed expectations in both military and civilian fields. Multiple field tests have shown the pulse laser's ability to take out enemy drones, disarm vehicles, shoot down missiles, and instantly jam communications. Currently, the laser's range is about 1 mile, though that is expected to increase with future upgrades. Even today, range is less of a limitation because the ultra-short pulse laser can be fitted to virtually any vehicle, jet, or ship, making it one of the most versatile military weapons ever developed. Imagine a military van rolling through an enemy battalion with this weapon mounted on top. There would be no need for sustained firing, as it could eliminate targets within seconds. Before TUSBL, hypersonic missiles were the U.S. military's most phenomenal next-level weaponry, missiles that travel at roughly 5 times the speed of sound, over 1,500 meters per second, coming in glide vehicle and cruise variants, and able to evade many defense systems due to their speed and maneuverability. The tactical ultra-short pulse laser, however, uses high-power fibers made from specially coated materials that amplify photons as they travel, strengthening the beam and making it extraordinarily powerful and precise. Thanks to these fibers, the TUSBL's beam effectively travels at light-like speeds and is extremely hard to evade, which is why it's so dangerous. Yet the same fibers also allow it to be optimized for non-lethal roles, such as disabling opponents without permanent harm. Another advanced feature is adaptive optics, which lets the laser adjust its beam to compensate for atmospheric distortions, a critical capability since a light-based weapon is vulnerable to environmental effects. The TUSBL is engineered to adapt to real-time agents and conditions so its intensity doesn't fall off over long distances. It can modify light intensity, wavelength, and other parameters to keep the beam focused and accurate regardless of atmospheric effects. That wavelength agility is crucial because some materials, so-called black bodies, absorb specific wavelengths. By changing its output, the pulse laser can overcome absorption, optimize performance for different environments, or use a continuous wavelength to minimize atmospheric loss, allowing it to maintain a high-power, concentrated beam across long ranges. The weapon also supports multiple beam configurations, letting it engage several threats simultaneously without sacrificing accuracy, and a beam sweep mode that rapidly scans an area to detect and neutralize clustered targets. Features U.S. Air Force experts say make the TUSBL an irreplaceable asset. Designed for remote and automated operation, advanced control systems let operators lock, target, and fire from a safe console at base, with dedicated subsystems such as a laser energy control and a beam quality control ensuring correct output levels, temperature, and stability. Despite its strengths, the TUSBL has practical constraints. Like any high-energy system, it requires effective cooling and managed firing cycles, since heat buildup can damage components or reduce battlefield effectiveness. So operators must plan duty cycles and cooling intervals to keep the system reliable. The TUSBL is engineered to adapt to real-time conditions so its intensity doesn't degrade over long distances. It can modify light intensity, wavelength, and other parameters to keep the beam focused and accurate despite atmospheric effects. That wavelength agility is crucial because some materials, so-called black bodies, absorb specific wavelengths. By changing its output, the pulse laser can overcome absorption, optimize performance for different environments, or use a continuous wavelength to minimize atmospheric loss, allowing it to maintain a high-power, concentrated beam across long ranges. The weapon supports multiple beam configurations to engage several threats simultaneously without sacrificing accuracy, and a beam sweep mode that rapidly scans areas to detect and neutralize cluster targets. Features U.S. Air Force experts say make the TUSBL an irreplaceable asset. Designed for remote and automated operation, advanced control systems let operators lock, target, and fire from a safe console at base, while subsystems such as laser energy control and beam quality control ensure correct output levels, temperature, and stability. Despite its strengths, the TUSBL has practical constraints. Like any high-energy system, it requires effective cooling and managed firing cycles, since heat buildup can damage components or reduce battlefield effectiveness. So operators must plan duty cycles and cooling intervals to keep the system reliable. By the time the TUSBL becomes a conventional weapon, it will likely see remarkable improvements, with features even more advanced than those described so far. Who knows? Perhaps the U.S. Air Force will one day optimize it to fire invisible laser beams, or even integrate it into a robotic platform, creating something akin to an Iron Man-style super beam. Speaking of robots and artificial intelligence, the U.S. military is already investing heavily in developing advanced AI-driven defense systems and weaponry, and it's not alone. Other world powers are also racing to integrate artificial intelligence into their military technologies, recognizing that AI could revolutionize warfare beyond anything humanity has ever imagined. The U.S. military has already deployed several autonomous and semi-autonomous systems, and it's hard to predict just how formidable the TUSPL could become if it were ever combined with AI capabilities. One thing is certain: as technology continues to advance, the sky is the limit. All we can do now is watch closely to see what the next mega weapon in America's arsenal will be.